So here are the problems from 9.3, or a problem. I guess it's actually two problems. One context, so two separate problems. So what I want you to do is, I want you to read the context. That's a paragraph, yeah. I want you to read what the problem's asking for, and I want you to start solving the problem on your own. And get as far as you can and pause the video, and then if you get stuck, use the video to help you out. So I'll give you a second now to pause this so you can try to work the problem on your own, and then I'll begin working it for you. Okay, so let's look what this problem's asking. It says, what's the probability that a randomly chosen person scores above, well, I'm having a little bit of technology issues here, above 625. So it's a probability, P, that X is greater than 625. So let's try this again. X is strictly greater than 625. And then we know it's a normal distribution problem, so we know we need to solve it that way. The way we know this is it says scores are normally distributed. So we know that this is the formula for our normal distribution. Z is equal to X minus mu over sigma divided by the square root of n, which is our sample size. So let's make a shopping list and see what things we may potentially need. Holy cow, let's try to fix this a little bit. Mu, this is a mu. Sigma and n. It doesn't get much better than that, does it? So what's x? X is 625. We know that because it's right there. (625). Mu, it says here the mean is 500, so this is 500. My standard deviation is 100 because that's what it says up there at the top. And my sample size. How many people are in my sample? Well, let's see what it says. What is the probability? A, randomly chosen person, and A means 1. So we put this all together. We have Z is equal to 625 minus 500 divided by sigma, which is 100. I looked off to the side for a second. I'm sorry about that. Divided by the square root of 1. Holy cow. This is Z is equal to, that's 125 divided by 100, which Mr. Hampton can do in his head, and it's 1.25. So a z-score of 1.25 translates to what? We get our z-table out, and we'll look at it, and make sure you realize this is a greater than. So 1.25. My final answer, P, is equal to 0.1056. If you got 8944, then you forgot to subtract it from 1, so make sure you do that. I'll pause for a second so you can write this down or take whatever notes you need to, and then we'll go on to part B. So for part B, I want you to do the same thing you did for A. Read it, try to work it by yourself, and then get some help from me. So I'll pause for a second again so you can read the context, which is the same for A, and then you can read what the problem's asking for. Okay, again, this is a normal distribution, and it's asking what's the probability. The scores are above 625. Oops. What's the probability that the scores are strictly above 625? And really what this should say is it should say the average. Let's see, it should say what's the probability group of 4 average score. So let me fix that a little bit. So that makes it more correct to what we're studying now. Average. average score is above 625. So since this is a normal distribution, we have the same formula we have had before. Z is equal to x minus mu over sigma divided by the square root of n, which is our new formula, but really it's the same thing we've always known. So we have an x, a mu, a sigma, and an n. And x is usually the easiest one. Remember, your x is always whatever you set up right here. So if you rewrite your problem correctly each time, it'll make finding your x much easier. My mean is 500 because that's what it is up here. It tells me. My standard deviation is 100, again by given. And my n, let me read the question. What is the probability group of 4? Oh, 4. So my sample size here is 4. Now let's see if we can work the problem. So z is equal to 625 for my x, minus 500 for my mu, divided by 100, divided by the square root of 4. So that's 125 over, and 100 divided by the square root of 4 is 50. So I get a z of 2.5. And it's greater than, so make sure you take that into consideration when you find your p-value. So I get p is 0.0054. And again, if you got 9946, you forgot to subtract this from 1. We subtract it from 1 because it's a greater than problem. So I want you to notice something. I want you to notice that the standard deviation on the bottom changed by half. So when we increased our sample size from 1 to 4, we decreased our variation from 100 to 50 because it's by the square root of 4. So if we wanted to, say, reduce our error, in this case our standard deviation, by a factor of 10, we would have to have a sample size of 100. It's a whole square root of x thing. Okay, hopefully this helped you.